Hi and welcome to the Cobot channel. This is the UK channel for Universal Robots. We're going to bring you the latest in technical innovations, talk about UR Plus products and how they can be set up easily. And each week we'll have an interesting guest who will interview on the world of robotics.
Hello, I'm David Leasley from Technical Support at Universal Robots. So today we're going to answer a question that sometimes we always get asked is about support file. So when customers send in questions to technical support, either via emails or our customer-facing portal, My UR, the first thing we will ask as tech supporters is, can you send in the support file? So the support file is held on the robot and it's the log information. So if we go into the log screen of the robot, we can see the log file itself as it's running. So we can see information, warnings and critical errors. And then on the far right, we have the support file feature. So this is where we can download the support file to send to Universal Robots. So we can help with program analysis or help with finding problems in your application. So the first thing I need to do is just plug in a USB into the teach pendant of the robot, and then I press support file, and then continue. The robot searches for the USB. I find that, and then I press save. And now the robot will start to save the support file. Okay, so once we've downloaded this log file, we need to analyze it. So I recommend that you don't rename it and you don't unzip it. We just put it onto our desktop. So here we have a log file from the robot that's already been downloaded. So if I just open this up, we can see the data that's in it. So we can see the serial number of the robot. So if I just click on that, and then we can see the recordings that the robot's taken. So these are the flight reports. And then we can also see the robot configuration information. So if I open that up and then I go to files, I can see all the programs and I can see the in-memory program. So this is the last program that the robot was running when it was taking data. So if you were unsure what program you were running, use the Polyscope in-memory program. And then we can also see at the top we have the programs. So these are all the programs in the robot. So these are every single program and installation file that we have. So now we need to analyze this in Log Viewer. So the first thing we need to do is download that. So if I go into our website, so this is Universal Robots website, I need to go to Service and Support. And then I need to go to Technical Resources. And I need to click on Technical Resources. Then this takes us to our support site. So we have articles, we have downloads. The first thing I want to do is download the Log Viewer software. So it's a free download, so I just click on download. And then I move down to software. And then I can see the Log Viewer software. So I check that box. And then we have the Log Viewer options. So we have the latest version. We also have the legacy version as well. So if I click on the latest version, I click on the link to download that. I can then download that file and then that will reside on my desktop. So I've already got Log Viewer running, so I can close that down. So if I open Log Viewer, so this is the Log Viewer software, and I've clicked and dragged that zipped up support file into the actual Log Viewer software. So now we can analyze it. So I'm only going to go through the basics of Log Viewer. If you want to see any more detail, I suggest you sign up to one of our service trainings. But the first thing we've got is the flight reports at the top, which basically are snippets of information that preceded the fault. So it's of course nice to know what the fault was that caused the robot to stop, but it's also good to see what happened just before that incident as well. And then we can see the log data. So this is all time and date stamped. So the first thing I do is I always go to log analysis. So if I click on log analysis, and essentially I want to see what was happening recently in the robot. So here, if I look at the month, I can see that we've had over 300 protective stops or incidents with protective stops, which is quite high and we wouldn't expect that. So normally when we're setting up an application, we see quite a high level of protective stops, but once the application is running, we shouldn't really see protective stops. The only time we should see protective stops is to protect somebody if they come into contact with the arm of the robot. So that says to me that something is not quite right with the setup of the robot. So then I can go to log reader, and now I can see the log data. So the first thing I'll do is just look at the flight reports, and these are the last faults that were happening with the robot. So if I go to the latest one, just loads that. So here we can see the actual positions of the robot, the safe mode, and these are critical graphs at the bottom. So these are actual and target currents. So we're looking at these to see if they match. We can see there's nothing wrong there. But we can see an error up here, which is error number 7. So it's errored out on line number 7. So if you wanted to know what that was, we can move over to our safe mode. And here we can see that error number 7 is a system emergency stop. So essentially the robot was emergency stopped. So there's nothing to really concern ourselves here. We can see the script line number. So if we wanted to interrogate the log file further, we could actually look at the script line and find out what part of polyscope the error was occurring. So I'm actually going to close this down. So what you'll see, it gives you 6 graphs. My first graph is the base joint. So now I can close that down. It's shoulder, elbow, wrist 1, wrist 2, and wrist 3. So now I'm going to go to the next file. I'm going to open that up. And now I can see different data. So now I can see the error mode is number 3, which is a protective stop. I can just, if you didn't know, we can just go over and we can see that 3 is a protective stop. So something has happened to stop the robot and a protective stop has been triggered. If I look at my target and my actual currents, we can start to see that something is acting on the arm. Something is pushing or pulling the robot as it's trying to carry out its movement. So that's on the base joint. That's on the shoulder joint. That's on the elbow, wrist 1, wrist 2. So here we can start to see we've definitely got some issues, because now we've reached the point of where we make the protective stop. We can zoom in as well. So if we left click on the mouse and we zoom in on that data, we can start to see that something was acting. So if I click on the protective stop to draw a line, so now I've drawn a line down. So here we can clearly see before the protective stop, something was pushing and pulling the robot that then triggered that protective stop. Once we've done that, all these flight reports are time and date stamped. So we can find the time and date stamp also in the log file itself. So if I just show you the log file and I start to open up the log file, so I just left click on the data, we can start to see collision detected in shoulder joint. So obviously these are areas that we want to investigate and find out why that was happening. If I want to know when that was happening, of course I can look at the time and date stamped, but I can also look at an average of a graph and put some time and dates in. So if I click on that error and I right click on that, I can then choose error selection timeline or error default timeline. So if I click on the first one, I then can see the graph. So these are the error codes that are generated in the robot and the log file, and these are the times and dates that those were occurring. And then what we can also do is we can export data from the robot. So as I said, I'm not going to go deep dive into what was causing the error. We'll cover that more in service training. I'm just showing you what log viewer is and how to use it. And now I'll show you how to export data from the robot. So also we can use the log viewer to record live data out the robot. So if we've got a problem with an application, you can connect your laptop to the robot and we can see areas of the application that might cause us problems and might cause a protective stop. So here I've gone on to record data, and then I'm going to record the data out the base joint, which is joint 0. I've connected to the robot, which is the IP address of this actual robot, and then I can set the frequency of what I want the download rate from the robot. So I've set it at 500 Hertz, and then I've also set it to record for 5 minutes. And this is the actual preset values that we can record out the robot, so we can customize that to whatever we want. So now I'm going to press start. And as soon as I start, it starts to open up some graphs in the background. So I'm just going to go onto those. So here we can see the live data coming out of the robot. So the robot's not moving, so we would expect that we don't see any spikes in the graphs. But if I start to move the robot, you start to see that we can see that have an effect on the robot arm. So we can see that how those graphs can help us to fault find. So now if I just run this program, so the robot's actually going to run, and our target and our actual currents are in line, which we would expect. But now if I start to have an effect on the robot, we can start to see that we see that in the graph itself. So we shouldn't see those type of spikes in the graph. But obviously when I act on the arm, so those spikes can be caused by incorrect payload setting. So when the robot's picked something up, it's not been dynamically changed to that new payload, so the actual and the target currents won't match. Or sometimes we see it on palletizing applications where the dress pack of the pneumatic pipes are maybe too tight, so when the robot's trying to move, the actual dress pack's restricting it. Also in welding, the umbilical for the power pack is actually holding the robot back, so we can start to see that spike in the actual joint graphs itself.
This week's application focus is from Cobots.ie in Cork in Ireland. Our partners have created a complete automated testing cell. At the heart of the cell there is a UR5E robot, which is inverted. It has a custom gripper that can pick up the product, present it to a camera so it reads the barcode. It can then present the same part to a different scanner to read a data matrix on the top seal of the part. These two codes have to consolidate together. And then, based on those, if they're a pass, the robot will take the part to a seal integrity tester, where the seal will be checked, and if that is a pass, the part is taken to the outfeed and passed out to the operator. So you can see the robot presenting to the scanner to read the barcode. It'll then also present the part to the same scanner, which will read the data matrix on the top of the foil seal. It then moves over to the pressure test, where it will test the integrity of the foil seal on the top of the canister. And based on that output, it can say whether a part's a pass or a fail. Now, this closed loop testing means that there is no human error in the complete testing regime. The robot is responsible for each step. The custom gripper on the end has a vacuum cup that can connect to the outside of the canister and hold it with enough force so that it holds it steady whilst it's reading the barcode. This was important to the end client because they didn't want to have lots of different types of tooling. Here you can see the seal being tested, and the cell records the entire force and all the codes, consolidates them together into a database. This also takes out the need for somebody to input this data, where it could be put in wrong and the codes might not align. This sort of testing is really important for laboratories. It takes out the human error and creates a much quicker turnaround time for results. And the entire test cell is controlled at the very heart of it by the robot. It is the robot that manipulates the parts, presents them to each different stage, and if there needs to be a change in this testing regime, then it's only changing software in the robot. There are no mechanical changes to make. This is perfect as part of an Industry 4 connected laboratory to save the results and grade the products
into pass or fails or leak or no leak. Should you want to find any more about this, you can find more from Cobots.ie, and their website links are in the description.
Hi, welcome back to Cobot Weekly. I'm joined this week by Matt Smith from LABMAN Automation. Hi, Matt.
Hi, Mark.
How are you doing? You okay?
Not bad, yourself.
Yeah, good. Can you tell us a little bit more about LABMAN and what they do?
So, LABMAN are a bespoke manufacturer of laboratory automation solutions. We're a family-run company based in the northeast of the UK. We've been going at this for over 40 years now, and we've delivered over 300 robots into over 40 different countries.
Excellent. And we're going to talk today a little bit about laboratory automation and where cobots can be used in that. So what seems to be the biggest challenge that laboratories face at the moment?
So labs typically have a lot of very mundane and somewhat archaic tasks. So lab technicians are often needed to do a manual operation several thousands of times in order to create the number of samples they need to run an experiment. We're also in kind of an area where vast amounts of data are generated, and in order to kind of enable these discoveries people are looking for.
So Matt, are there any of your customers that have asked for cobots specifically in that laboratory environment?
So we have a handful of customers where they're very keen on how the user experience of interacting and how a system kind of fits into a lab workflow works. So what they're actually looking for is, rather than a off-the-shelf kind of standard cell, which is all enclosed and a user basically manually loads it, sets it off, walks away, is they want something that's kind of sat there in the lab, constantly running, and users can literally come up and place a sample on the system for processing. And then the moment that sample then finished, the user automatically gets the data without having to leave their desks. And that way, these systems then really seamlessly sit in a lab workflow rather than just being a tool within the lab. And what we find there is that's really key where collaborative robots fit in, because we want something that's open access. We want something where a user can literally come up and directly interact with the cell. So that's, again, another example of where we've worked really closely with UR to be able to actually integrate systems in a way.
So Matt, how can flexible automation and cobots be used in laboratories to help with efficiency?
So the nice thing about collaborative applications is that they're very adaptable, and we can change up kind of the workflow they're performing very quickly. That's kind of really key in a lab environment where the scope of what an experiment might be looking at, or kind of what a wider work package might be looking at, needs to change and be very adaptable to kind of the change of a business or kind of change to world events.
And what kind of typical tasks can be automated to optimize that productivity?
So typically we look at automating tasks that are kind of quite mundane or archaic, so stuff like automated weighing, where a lab technician might have to weigh out several thousand samples. These are tasks that are kind of much more adaptable and better suited to a cobot, because we've got lab technicians, we're paying a lot of money, and we're typically very clever people, and they're going to spend quite a large proportion of their day weighing out several thousand samples. That are better suited to them going off and doing something more valuable, such as data analysis or design of experiments, and we can leave the robot to just simply run and get through them tasks.
We've seen tasks that people have asked to automate where they're just agitating some material in a flask. It's just somebody stood there shaking a flask about for half an hour, which seems a really poor use of a technician's time.
And what we'll see again there is that the cobot is far better suited to that task. It's more repeatable. We can get far more accurate control over such as agitation speeds. And actually delivering a collaborative application is kind of, it pays for itself very quickly in a lot of these lab environments. We've put solutions out there where we've seen them pay back within kind of 3 months of it being delivered on site.
Excellent. And you touched on like data analysis and being able to gather the information from those tasks that the robots are doing. How important is that a factor for people to consider when they're looking at flexible automation?
It's really key. So the whole point of these lab technicians running these experiments is to gather data. But actually, by automating the solution, is what we see is we can cover a wider set of experimental parameters, because we can run 24/7. We can kind of look at a broader scope of experiment parameters, which actually allows us to enhance the discoveries we're making with these systems, purely because we're gaining knowledge on data that we wouldn't have typically been able to exploit.
And do you think connectivity to the cloud is kind of important? It's something to consider for when putting these kind of cells into production?
Yeah, definitely. So that's one thing we've done really key with all of our systems is we've got a cloud-based telemetry and tracking service that's free of charge with all of our robots. It doesn't capture any of the experimental data that's kind of private to that end user. But what that allows us to do is basically monitor these applications out in the field, and we can see when things might start failing, or whether we need to go and kind of change out a gripper after several thousand samples. It allows us to kind of better support our customers and keep these cells running.
So it's almost like a remote monitoring
sort of
piece of equipment and piece of software that you can analyze that as it's working in real time.
Kind of, it also allows our customers to see how these systems are being used and utilized within the lab environment, and see where kind of bottlenecks within workflows start to occur.
And we kind of touched on this earlier on. So what are the main sort of design considerations that LABMAN took when using universal robots? Why use us?
So all of our systems, the design principle is very collaborative with that end customer. So throughout the entire, from an initial kind of inquiry into the company to us actually developing a solution, we work very closely to and from with the customer to be able to design a solution that meets their needs perfectly. And part of that, it kind of is an initial technology scope where we'll go and look at exactly what's out there on the market and kind of the best fit for a specific application. So we'll contact people like yourselves and other manufacturers, and we really are looking for a product where they can help us to be able to exploit the best kind of technical challenges for that initial application.
Yep.
So with yourselves, it's kind of the support. If we have an issue, we can actually get a response within 4 hours. We can have parts on site the next day. But we're also looking for something that's really easy to be able to use and kind of adapt if a customer wants to change it. And that's something where Universal Robots has particularly felt really with what we need.
And that's kind of in our design aspect for the robots, really. We've made them like that to be usable and supported by the UR Plus products as well.
It's also really good for when we end up with a lot of unique proof of concept systems internally. So they're kind of very quickly put together just to be able to prove a kind of quick concept. The nice thing about using a UR in that sense is that we can have one up and running within about an hour of getting it out of the box and programmed for doing a very simple pick and place task, whether we want to check some consumables, pick and place nicely, or whether we want to run some powder feeding. It's very quick for us to be able to adapt and change that.
Is that important for you guys then? That's one of the main things that's appealing.
That's crucial not only for us but also for the end customers. So we need to be able to de-risk them applications, and we need to be able to prove to them that we're picking the right technology before we might go on and spend millions of pounds developing an end-to-end platform.
Yeah, so they can actually see a 6-axis robot carrying out the task that they want to ultimately carry out in their labs.
Yeah.
So what sort of main benefits can end users see from automating their laboratory processes? We talked about taking away the lab technicians from the sort of dull and tedious, but what other kind of benefits can they see?
So the main benefit, it really allows them to be able to cover a wider set of experimental parameters and kind of broaden the scope of the experiments they're running. So something where we might have typically been able to only look at a handful of parameters, we can now look at several thousand parameters. We can implement and integrate new things over time. So if an experiment wants to change, we can kind of take that, readapt that workflow, and then easily redeploy that out on a system.
So anecdotally, one of the things that we get told quite a lot is being able to put a cobot into a lab actually saves time. It's a really precious resource, and that frees up time for technicians to concentrate on more valuable tasks, but also shortens turnaround time for samples, and that might mean a day less in hospital for somebody to free up a bed and so on. So that's where we see the main benefits from it. So Matt, thanks for joining us today.
No problem.
That's all from Cobot's channel this week. Join us next week when we'll have another guest. We'll see you then.